Okay, welcome to the second review video for AP Calculus, and the topic of this unit is going to be the introduction to derivatives. So let's look at the first problem here. So we're given the limit calculation for the derivative of f of x. We're supposed to find f of x and find where the derivative is being calculated. So before we start, to be able to solve this question, you're going to have to know the formula for the limit calculation of the derivative. There are two common forms. The first one is the limit as x approaches a of f of x minus f of a over x minus a. And the second is the limit as h approaches 0 of f of x plus h minus f of x all over h. So when we look at part A here, we notice that it's looking very similar to the top formula. We have a function minus a value over x minus a value, and then this a is the same as this. So there's probably like a match here. And then the one thing we want to double check is that the f of a is square root of 3. So is f of a equal to square root of 3? And then remember a is pi over 3, and then f of x would be tangent of x. So is tangent of pi over 3 equal to square root of 3? Well, yes, it is. It is equal to square root of 3, so we're good. What that means is we know that for part A, f of x is tangent of x, and a is pi over 3. And then for part B, it's looking like the second definition, because we have a function of x plus h, and then we have just the x, and it's looking like, so we have 3 times something to the 5th power, so it looks like f of x is 3 times x to the 5th power, and then the x value here is what's in the parentheses. So in the parentheses we have 1/2, so x is 1/2. And what that means is, for this question, we're taking the derivative of 3x to the 5th at the value of x equals 1/2. Okay, so that's the answer to part 2. Alright, so looking at question 2, we're asked to find the second derivative for these two functions. So let's start with part A. We're asked to find the second derivative of 4x to the 3rd power. And then, so first we're going to start by finding the derivative. And then the derivative of 4x cubed, we're going to use the power rule. We're going to bring the exponent down, so it's going to be 4 times 3x. And then the new exponent is going to be reduced by 1. So it's going to be 4 times 3 is 12, so we're going to have 12x squared. But remember, we're not finding the first derivative. We're finding the second derivative. So we're going to go one more step further, and we're going to take the derivative of our derivative. So the derivative of 12x squared, and it's going to be the exact same way. We're going to take the power, bring it down. So it's going to be 12 times 2, and then the power is going to be reduced by 1, so 2 minus 1. So 2 times 12 is 24, and then 2 minus 1 is just going to be 1, which is 24x. So that is our derivative this is our second derivative of 4x cubed. And then looking at part B, cosine of x. So let's take the first derivative. I'm going to use the alternate notation here. So I can also, instead of saying d dx, I can also say g prime of x. And that means the same thing. So the derivative of cosine of x is going to be negative sine of x. That's just something that needs to be memorized. There's not really anything else to it. And then we're going to take the second derivative, so g double prime of x. And then the derivative of sine is cosine, but remember we still have this negative here, and that's still going to stay. So negative cosine of x, because the derivative of sine is cosine, and the negative is tagging along. So our second derivative is negative cosine of x. So the second derivative of cosine is negative cosine. Okay, so here's the third question and the final question. So we're given three functions here. We're given f of x, g of x, and h of x, and we're finding derivatives of different combinations of these functions. Okay, so let's start with part A. Part A is asking for the derivative of f of x minus g of x. So f of x is secant squared of x, and then g of x is tangent of 2x. So we're finding the derivative of that. So remember, using the difference rule, I can split this up into the derivatives of these two functions separately. So this is just equal to the derivative of secant squared minus the derivative of tangent of 2x. And let's solve the derivatives of each of these. So we'll start with the derivative of secant squared, and I'm going to use the chain rule here because I have a composite function. So first I'm going to start with the squared part. I'm going to take this 2, bring it down, and I'm going to get 2 secant of x. And then now I need to multiply by the derivative of secant. Remember that the derivative of secant is secant tangent. So I'm going to multiply this by secant x tangent x. If I want to simplify this a bit more, I'd get 2 secant squared x tangent x. And then the second part is the derivative of tangent of 2x. And then now, first the outside function is the tangent, so I'm going to take that derivative of tangent, which is secant squared of 2x, and then multiply by the derivative of 2x, which is 2. So that's going to be 2 secant squared of 2x. Now putting that back into our original problem here, we're just going to take, so the derivative of secant squared x is this stuff up here, the derivative of tangent of 2x is this stuff down here. So our final answer is going to be this minus this. So 2 secant squared of x tangent of x minus 2 secant squared of 2x. And that is the answer for part A. Okay, so let's move on to part B. For part B, the question is the derivative of f of x over g of x. So that's going to be the derivative of secant squared of x over tangent of 2x. And for this we're going to have to use the quotient rule. So remember, the quotient rule is bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So we're going to start with the bottom, which is tangent of 2x, times the derivative of secant squared of x. Remember, up here, we said that the derivative of secant squared is 2 secant x tangent x. So I'm just going to write that here. 2 secant square x tangent x. And then I'm going to subtract from that the top, which is secant squared x, times the derivative of the bottom. Again, we already did the derivative of tangent of 2x. We already said that is 2 secant squared. So it was 2 secant squared of 2x. So I can write 2 secant squared of 2x here. And remember, what we just did the quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom. Now it's all going to be over the bottom squared. The bottom is tangent of 2x, so this is all going to be over tangent of 2x squared. And that is our answer for part B. Okay, let's look at part C. So, part C, the question was the derivative of secant squared of x over x times the tangent of 2x, right? H of x was x. So here we're also going to use the quotient rule, but we also have two functions being multiplied together, so we're going to use the product rule as well. But anyways, let's get started. So we're going to have the bottom x tangent of 2x times the derivative of the top. Again, we already said, well, the derivative of secant squared is going to be 2 secant squared x tangent of x. That's from part A. And then we're going to subtract the top, which is secant squared x, times the derivative of the bottom. And now for the derivative of the bottom, we're going to have to use the product rule. So remember, for the product rule, it's going to be one of them times the derivative of the other one plus the other plus the opposite. So it's going to be x times the derivative of tangent of 2x, which is 2 secant squared 2x, plus tangent of 2x times the derivative of x, which is just 1, right? The derivative of x is just 1, so that's our product rule part. And then we have bottom times the derivative of the top minus the top times the derivative of the bottom, and this whole thing is going to be divided by the bottom squared, so x tangent of 2x squared. Okay, and that is our answer for part C. Now let's move down to part D. Part D asked the derivative of secant squared of tangent of 2x over the square root of x. Okay, and again, this is just going to be, even though the function is getting more complicated as we go down, it's just like, can you work your way slowly through all the different rules that are involved in taking these derivatives. So we're going to start with the bottom, square root of x, times the derivative of the top. Okay, so let's think about how to take this derivative. First of all, the whole thing is being squared, right? So we're going to use the power rule. We're going to take the 2, bring it down, and we're going to get 2 secant of tangent of 2x. So we're done with that. And then now let's think about the secant. The derivative of secant, remember, the derivative of secant of anything is secant of whatever times tangent of whatever. So the derivative of secant of that is going to be secant of tangent of 2x times tangent of 2x. And then, so we're done with the secant part. Now we can look at the tangent. The derivative of tangent of anything is secant squared of anything. So we're going to multiply by secant squared of, well, what's left? After we take the derivative of tangent, we're going to have the 2x. Okay, so we're done with the tangent. So you look, we're just working our way in slowly but surely. And we just have the 2x left. The derivative of that is 2. Okay? And then now we're going to subtract the top, which was secant squared of tangent of 2x, times the derivative of the bottom, so the derivative of square root of x. Now this is just something you're going to want to memorize because it comes up so often. The derivative of square root of x is 1 over 2 times the square root of x. Okay, and then for the final part, we're going to have this whole thing from the beginning all the way to the end. All of this is going to be divided by x. Right? So I'm going to try and fit all this into one line so it's a bit more clear what's going on. Okay, so here is the final answer for my giant derivative. Right, this is part D right there. And even though this looks really complicated, remember, the way we did this, we just slowly worked our way through the chain rule, the product rule. Well, not the product rule in this case, but up here, we did use the product rule in part C. And in part D, remember, we just slowly, the chain rule, the quotient rule. If you know the derivatives of your functions and you know the order that you're working from the inside, from the outside in. It's really just like a matter of going step by step and following the process. And then another big thing is making sure, don't simplify your answer. Even if you can combine stuff, don't waste your time. Because if you somehow make a mistake, you're going to get penalized even though you had the right answer all along. So just keep it like this, it's fine. As long as your answer here is equivalent algebraically to the correct answer, you will still get credit. At least that's how it worked in my school. So yeah, that's gonna be all for this video. See you later.